So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. We're talking about backup power on this week's show. So if you're a solar installer, listen up. There's some interesting observations. If you're a homeowner, definitely listen up because these systems now make sense. And if you're a manufacturer of these battery backup and solar systems, you might learn a little bit about what it takes to get them installed for customers' houses. All right. I've been installing backup power systems on and off for almost 20 years. I used to install lead-acid solar and battery systems. We use these really fairly reliable trace inverters, Morningstar and Trace charge controllers, lead-acid batteries, customized enclosures. We had to kind of make the wiring up out of what we could get at the auto parts store, and lots of fiddly little settings and wires and things like that. There was no remote monitoring. There weren't package systems. I mean, sometimes you could get this whole monster thing pre-installed on a pallet, but it was a lot of work. And the thing is, the batteries required too much maintenance for most customers. So because of all the maintenance that was required and the questions that customers had, and really candidly, the limited lifespan of most of the systems, I mean, they really only had good power for about 5 years before the batteries started to go. We stopped installing them about 15 years ago. Essentially, they were too complicated, too much maintenance, and not a good fit for most homeowners, because homeowners just want something that they wanted to put in, and they don't want to worry about it. And it's still kind of the case with a lot of these older off-grid lead-acid systems. I have a friend who installs these things, and he says he has most of his customers on the speed dial of his phone because there's just so many questions and so much little adjustments that need to be made. So I couldn't in good conscience continue to install these systems without the reliability that I've come to expect. They do work really well for off-grid customers, off-grid homeowners. Generators work pretty well in those situations, but the new technology, I think, is really changing what's going to be installed. And plus, the need for backup power has changed, as well as the economics for backup power. So now, I'm a big fan of battery storage systems coupled with home solar. I mean, even a year ago, I was skeptical. But now that the new products are out, they're stable, they're reliable, they're from major manufacturers, and we at Cinnamon Solar have tested them, and they're working. And most importantly, the economics are pretty good. And so I kind of took a step back and said, what are the three basic needs that these backup power systems need to meet? Well, the first need is with high time of use electric rates and incentives, we have good economics. So we're meeting the economic needs for customers. And the second need is we have unreliable power and we have a lot of reliance on electricity. So when there's a power failure, we really need backup power, a lot more than 20 years ago even. And the third need that these systems are now meeting, which is a little bit more subtle, and I kind of scratch my head and say, this is why we're getting back into it, is with better integrated systems and bigger manufacturers and more stability within the industry and new technology, contractors like your home and business solar installer, like Cinnamon Solar, now we can install these systems profitably. There wasn't really a profitable way for a solar contractor to install battery backup systems. We just couldn't make enough money on it to make it worth it. You know, we got to pay our employees. We got to make some money. But now with these newer systems, they're stable enough and reliable enough that there actually is a business opportunity there. Okay, so let's kind of look at these three factors. We'll start with the economics. Now, the economics, homeowners and business owners benefit. And you can do two things at a home that make these things really pay off. One is you can kind of you can shift your usage of electricity, rate arbitrage. It's just a time of use thing. So there's low time of use rates during off-peak periods. And these off-peak periods used to be, in the middle of the night, and they used to be in the afternoon and evening. And then they have high rates during peak periods. Now the peak periods and the off-peak periods have changed just because there's so much solar generation on a utility scale on the grid. So the most popular EV rate in California, here in Northern California, this is something that a lot of our customers use. It's the EV time of use rate, and it works great with solar if you have an EV. It's 45 cents a kilowatt hour if you're using energy from 2 p.m. in the afternoon to 9 p.m. at night. Heck, that's when people are home. That's when you're cooking dinner, cleaning up, things like that. That's when you get hit with the highest rates. It's 25 cents a kilowatt hour from 7 a.m. in the morning to 2 p.m. People wake up. You're not really doing a lot of things. There's no air conditioning demand huge at that point. And there's also plenty of solar from 10 to 2. In the middle of the night from 11 p.m. to 7 a.m., it's 12 cents a kilowatt hour. That's when you charge up your car. So what you can do is you can charge your batteries during the day, and you completely avoid that 45-cent kilowatt hour power from 2 to 9 p.m. It's great. If you have a battery, basically, you're saving 45 cents a kilowatt hour. It's terrific. Just look at an example. Let's say your system generates 10,000 kilowatt hours a year. That's kind of a normal size solar system. The regular solar system will save $2,500, but if you have batteries, and you can now, instead of saving 25 cents a kilowatt hour, you can save the 45 cent a kilowatt hour, your savings can be more like $3,500 a year. That makes a big difference. Now, also, some locations, some utilities, some states have incentives for battery storage, and that even reduces the upfront cost even more than the cost reductions have happened as far as the equipment. So here in California, as part of the self-generation incentive program, homeowners and businesses can get a $4,000 rebate even on a small battery backup system. And you can get hundreds of thousands of dollars for bigger systems, but small systems, $4,000 check from the government. That's pretty good. And you get to take the investment tax credit for solar and storage. So that'll save another $5,000 on a typical solar and storage system. So it is really a way to reduce those costs. Okay. Now, why do they have these incentives? Well, the incentives help take this extra load off the grid. The utility get incentives for storage for very large systems that they install at substations. So PG&E might get $1 million incentive for putting a whole, tons and tons of batteries at local substations. Businesses and homeowners can get the same kind of incentives for smaller systems they install for their own benefit. That's kind of called behind the meter. And as electric rates continue to go up and as time of use periods continue to shift away from when you're generating solar towards the evening, and as demand charges, these are per kilowatt charges, not kilowatt hour charges. Businesses pay these in California, but I think they're going to start happening to consumers. There's going to be even additional savings for battery storage. All right, second reason for solar and storage, and this is really, from a society benefit standpoint, from a ratepayer benefit, the grid is not getting more reliable. It's getting less reliable. The central generation of power is actually pretty reliable, but by the time the power gets to homeowners and businesses, the local grid's really not up to it. I experienced 2 extended blackouts in my San Jose home this year from local grid failures, and 1 blackout for 4 days from a storm. We'll get to that in a minute. So why do we get these grid failures? The grid is not designed for so many electrical appliances that we have. It wasn't designed for heat pumps instead of gas hot water heaters and gas furnaces. It wasn't designed for all the air conditioning that's going in. It certainly wasn't designed for EVs. Utilities are trying to update it, but they're not updating it that fast. The local grid's getting overlooked. So what's happening is you kind of look at what's the cheapest way to upgrade the grid. Well, we can pay the utilities to upgrade the grid, and they're going to make their 10% rate of return on that. Or homeowners and businesses can kind of upgrade the grid on their own with solar and storage, and that makes a lot more sense. Finally, from a storm and emergency standpoint, it's just been crazy this year. We've had several hurricanes, the hurricanes in Texas, Hurricane Irma in Florida, Hurricane Maria in PR. Basically, Maria wiped out the complete local grid. It's going to be months before power is restored in Puerto Rico. And now we've got fires in Northern California, and these are all kind of wiping out the grid. So generators are okay, but not for really an extended outage. Solar and storage is really the best solution. Now, the third reason, and this is kind of interesting. For contractors, listen up. You can actually meet your customers' needs for backup power and battery storage and saving more money by doing this rate shifting and time of use arbitrage. And you can make a little bit of a profit. Couldn't do that with old-fashioned grid-tied lead-acid batteries. They just require too much babysitting, too much maintenance. The new lithium-ion battery systems from a bunch of companies like LG Chem and some others, they really are pretty reliable, and they work with special inverters that are also reliable. They have the communications capabilities built in so that you can often monitor and even change set points without having to go to the customer's site, which is great. So contractors now can install these systems and have confidence that the systems are going to be low maintenance, and they can actually have a profitable side business doing these storage systems. It's not going to be the major part of the business, but eventually, who knows? So storage and solar is actually turning into a viable business. Okay, now let's talk about the options for backup power. All right, we'll talk about generators first. All right, and we're just going to kind of go through the low end to the high end choices here. All right. So you can go to any of the big box stores and get a basic emergency power generator. It's going to come in a big box. It's going to weigh a couple of 100 pounds. You can get an inexpensive 4,000 watt generator for about $500. And you can spend more money, $1,000, $1,500, to get something that's going to be quieter. It's kind of interesting that the cheap ones make a lot of noise. The higher power ones and the quieter ones typically cost a lot more money. And they're powered from either gasoline or propane. Gasoline, you just go to the gas station, get a couple of 5-gallon jugs of gas, and then you kind of keep that near the generator. And if there's ever an emergency, fill up the generator and it'll run. Some of them are also propane powered and some of them dual fuel. So that same propane tank that you use for your gas grill, you can use that for your generator. I've had one of these 5,000 watt generators for over 20 years. And when I have a blackout, I just drag the thing outside. I plug it in, pull the cord. Then some of them have electric starts. That's going to cost a little bit more money. So you just push a button to start it instead of pulling that cord. And then it fires up. And then I plug the appliances in and lights in. Or I can plug it into a special connection in my house. And I've got plenty of power for as long as I have gasoline or propane. Generator might have a 10-gallon tank, and that tank might last 5 hours or so, depending on how many loads you're running. But it just works. And it's good in a pinch for a short blackout. And the way I kind of look at it is I always have some extra gas sitting around, and I have some gas in my car. So if there's a really big blackout, I can even siphon some gas out of the tank. Now, the next step up with generators is get the basic kind of generator, but you put in some more electronics in your house. You put in a transfer switch or a backup sub panel. And this is a big switch that your electrician can put in, or your backup storage guy can put in. And it's going to rewire your circuits a little bit so that you can plug the generator right into the electric circuits in your house. Now, your generator, if you have a big generator, 5, 6, 10,000 watts, it can probably power your whole house except for your air conditioning. If you have a little generator, it can't power that much, and you can just put in this dedicated sub panel. Now, these backup panels are very, very handy. And they're also used for battery storage systems. So I'll talk about it a little bit. So these are called critical load subpanels or backup subpanels. It's a special electrical panel, and your electrician will go into your electric circuits and say, we've got a circuit here for your kitchen appliances. We have a circuit here for your lights in your kitchen. We have a circuit for your furnace that's running the fan in the furnace and maybe your hot water heater. And we have a circuit for some lights and maybe your TV and entertainment systems. So the electrician is going to pull out maybe 5 circuits, each of which might be 15 or 20 amps, and he's going to run that into a separate panel. And your generator or your battery storage system is going to be powering that separate panel. The battery storage system will power it all the time, but it'll also get grid power. And that when you're using a generator, it's only going to be powered from the generator when you flip a switch. So normal operation, that backup panel is powered by the utility, but if there's a blackout, flip a switch, and now that backup panel is going to be powered by the generator. It's kind of a handy thing. Costs you maybe $1,000 to $2,000 for your electrician to do that rewiring. Not a big deal, and I would recommend it because when you're having a blackout, there might be a storm, a pain in the neck. You don't have to want to start farting around with things. You just want to plug in the generator, push the button, and start it. Okay, the next step up, kind of a high end, is a whole house generator. These things are usually powered by natural gas. They're plumbed in by a generator contractor, and they plumb in the same gas that you have powering your, that heats your furnace. And it's some heavy duty cast iron pipe. And these things usually have either an automatic, which is expensive, or a manual transfer switch. So when there's a power failure and you want to run the generator, you flip this transfer switch and then start the generator. Sometimes the generators have auto start capabilities. Usually these big generators all have battery starters. But they're going to cost $10,000 to $20,000. It might make a lot of sense if you really need power, if you want to power your whole house, if you're worried about a disaster, if you're in a place that kind of gets frequent bad weather and hurricanes. And certainly we've seen a lot of those over the past year. And then even over the last 10 years, quite a few. So that's the generator. That's kind of the low-end way of going with things. You can get started for less than $1,000, or you can get a whole house generator. But what's really exciting to me and what's really changed are new storage products that are connected to the solar panels. Now, the big advantage of connecting battery storage to solar is that the solar is going to recharge your batteries every single day. So this is kind of like the standard solar array that people are putting on their houses, but then there's a special inverter and dedicated batteries that are connected to these panels in a way so that you'll be running on batteries in the evening. Batteries get depleted, and then the solar charges those batteries up every day. You kind of go through those cycles. And the thing I really like is that some of these new batteries that are out there, they're guaranteed to have enough capacity to last 10 years. They're usually lithium-ion batteries. and they have lots of capacity. Now, a couple of limitations. The power output, the amount of power they can provide is about the same amount of power you get from a small generator, like a 5,000 or 6,000 watt generator. So it's going to be enough power to power a critical load subpanel. It's not going to be enough power to power your whole house, especially things like a central air conditioner, or if you have an electric stove or an electric oven. Usually the inverter that works with these battery storage systems doesn't have enough power output for an electric oven or a central air conditioning. So we put in a critical load subpanel just like you do for a little generator. Not that big a deal. So here's how it works. As long as there's utility power, your solar's working. It's just like you have a regular solar system. The critical load subpanel, as long as utility power is there, is always getting power from the utility. So these appliances, they don't blink. They don't notice there's a difference. But if there's a power failure, the inverter automatically switches into a different mode, backup mode. Some of these things switch over instantaneously. More commonly, they might take about 10 or 20 seconds to switch over into backup mode. You hear some clicks, some relays, and then boom, after about 10 or 20 seconds, the battery is now going to be powering those critical loads through the inverter. So you're going to have power to your furnace and to your lights in your kitchen and your refrigerators and your entertainment system. You can recharge your cell phone. You can watch TV, do anything like that. All totally automatic. It's great. I think it's a great option for new solar systems because these systems are now fairly reliable. I mean, I'm not going to go to the mat and say they're going to be perfect, but they're from major companies like LG and SolarEdge and Enphase. And I got a lot of confidence that those companies are going to be around in one way or another for many, many years. So if you're looking at getting solar, all you need to do is add a battery and an upgraded inverter, and there's a little bit more electrical wiring. So when I kind of look at the incremental cost after the tax credit and after the local incentives, it's going to add maybe $7,000 to $10,000 to your solar system. You know, if you have an existing solar system, it's going to be a bit trickier. You're going to have to talk to your solar contractor and see how they can retrofit one of these things, but it can still be done. And even if you have microinverters, there are battery backup systems that you can probably install, and we're still testing those at Cinnamon Solar, but there's solutions that you can put in place, even if you have microinverters that are going to give you the backup power that you need. Now, another big benefit of solar and storage when you combine these systems is many places, that we talked about earlier, they have really high time of use electric rates. So with one of these battery systems, when you have really high electric rates, like here in PG&E on the EV rate, 45 cents a kilowatt hour from 2 p.m. to 9 p.m., solar's not going to help you then because the sun's down. It's no coincidence that that's when the utility moved the time of use rates into those hours. Now the rates during the middle of the day, they're not really high anymore. It's kind of ironic that I'm complaining about low electric rates, but they're not that favorable to solar. So what you can do is you can store the electricity that you generate during the middle of the day when you really don't get a lot of credit from the utility, and you use that electricity at night. So you're charging the battery during the day and using that power at night. It works really, really well. All right, how do you choose? Okay, so here's my kind of summary nutshell advice. If you're not thinking about solar, if you don't have, a really sunny roof, if you're kind of tapped out, you don't have money, if you don't have any credit, because you can get these systems on credit. There's great PACE loans and things like that that'll help finance it. But if you really only want to spend $500,000 and you're worried about blackouts and things like that, my advice, go to one of the big box stores, get a small generator, $500, get some extension cords, make sure you can install the generator in a safe place and run it safely. If you want to spend some more money, you can get a bigger generator, you can get a quieter generator, you can have it wired into the house with a backup subpanel and a transfer switch, or you can get one of the higher end generators. But that would be my advice if you're not going solar. If you're thinking about solar at the same time, you should definitely look into the benefits and the economics of a battery storage system. You're going to save money on your electric bill. You're going to save even more than if you had a regular solar system because these battery systems can now do that time shifting. And you have almost unlimited backup power duration if there's a blackout, because this is what happens. If there's a blackout, bad weather like happened to me in February in San Jose area, my power was out for 4 days. I didn't have enough gasoline to run the generator kind of constantly or even as much as I had. So, my wife and I were rationing the gas. We would run the generator for, maybe 4 times for an hour each just to make sure that the fridge was charged up and the house was heated up. We didn't want to kind of run it constantly. But if we had a battery backup system, heck, we would have those appliances would have run just fine and the heat would have just been running just fine. And yeah, some of the house would have been dark and I might not have been using the electric stove as much. I would have just used the microwave oven, but it would have worked out great. So these battery storage systems add maybe $7,000 to $10,000 to the cost of a basic solar system. More than a generator, much less than a whole house generator. And I think they're going to be much more disaster resilient because if there's a really bad disaster, a hurricane or, fires like we're having in Northern California, even the natural gas system is going to be knocked out. You're not going to have any natural gas pressure. You're not going to have any heat in your house. But guess what? If you have solar on the roof, as long as the roof isn't blown off from the hurricane, you're going to be able to run that battery backup system just fine. So I think it is the most disaster resilient option. Not that I'm paranoid, but something to think about. All right. That's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.